Hello, this is Miss Poor, and we're going to work on Unit 3, Lesson 302. Just didn't have time to cover it yesterday in the general session, so I'm going to cover it for you now and shoot out this recording to you. The objectives of 302 are to divide a polynomial, by another polynomial, which is, remember, super easy now that we're using the synthetic division method. And then use the factor theorem to test for a factor of a polynomial, and then use the remainder theorem to evaluate a polynomial. And here is our vocabulary for Unit 302. It says the remainder produced when dividing f of x by the binomial, the difference of x and k equals f of k. And I think we're going to call that the remainder theorem, if I hope I'm right. And the next one says if the remainder equals 0 after synthetically dividing f of x by a number k, then the difference of x and k is a factor of f of x. And hello. I'm just going to go ahead and put this in here. But what I just read to you was the factor theorem. And then a process for dividing a polynomial by a linear binomial using coefficient but no variables, synthetic division. Okay, right now what I'm going to start out doing is we're going to use, I was hoping that was moved, use long division to find the quotient and the remainder. And I bet you guys love doing long division. I know it's everybody's favorite in math. Right, so let's go ahead and get this divided. We're going to take 2x cubed plus 4x squared plus 0x minus 5, and we're going to divide it by x plus 3. Now then, if you look in the original problem, there is no 0x. We always have to throw in the variables of all powers. So we started out with 2x to the third. They had 4x squared, but they didn't have a linear x. So we had to add that one. You always have to do that when you're working this long division. So the first thing I'm going to ask is how many x's will it take to get 2x cubed? Well, y'all probably know that answer right away. Let me get my handy-dandy pen going here. I always know when I can't find it, I'm using it upside down. Just ignore that little dash. So we know that it's going to take 2x squared. So if we say x multiplied by 2x squared, we're going to get 2x cubed. And then we're going to bring down, no, we're not bringing down yet. Sorry, I got all excited there. Now we've got to take and multiply. We've done the x times the 2x squared. Now we've got to multiply the 2x squared by 3. And we're going to get 6x squared. Now remember from when we learned long division without variables and all way long time ago, when we found out it was our favorite thing to do in math, we always subtract. Now those parentheses are pretty important because what happens is it's changing everything in the parentheses to the opposite sign. So now we're going to have a negative 2x cubed, and we're going to have a negative 6x squared. And that's going to give us, I'm changing back, I'm going to use blue now instead of black because it seems to write better. So 2x cubed minus 2x cubed is going to give me 0. 4x squared minus 6x squared is going to give me a negative 2x squared. And then I'm going to bring down, now I'm bringing down. I got ahead of myself a while ago. 0x. Now I have to say how many x's, and I'm looking at the x right here. I was trying to draw a check mark. How many x's is it going to take to get a negative 2x squared? Well, we're going to say 2x. So, 2x squared multiplied by x is going to give me 2x squared. I really want that to be a minus. I'm going to go back, and I think in my little notes here, I meant for that to be a minus, and I put a plus. Because in order for it to work, it has to be a minus. And then a negative 2x multiplied by 3 is going to give me a minus 6x. So remember that negative, oh, close my parentheses, that negative sign, this minus right here, that's going to change the signs of everything in the parentheses. So let me get my red pen right here. So now this is going to be a positive 2x squared, and this is going to be a positive 6. And if you're a little rusty with your long division, you're going to have to do a couple problems in either your practice problems or your assignment to show that you kind of grasp this concept. But when we start using the synthetic division, it's going to be so much easier. So here I've got a negative 2x squared plus a 2x squared is going to give me 0. And then I have a 0x minus 6x. 0x plus 6x is going to give me 6x. Now I'm going to bring down that 5. So now I say, okay, how many of these x's is it going to take to get 6x? Well, hello, that is plus 6. So 6 multiplied by x is going to give me 6x, and let me put my parentheses in my minus sign right there. 6 multiplied by 3 is going to give me a positive 18. And then remember, everything in there, the signs changed. So I've got a minus 6 and a minus 18. I like changing it to red so that way when I put that minus sign above the 18, I didn't do anything with the plus sign. I just let you know, oh, now it's negative. So I got 6x minus 6x, that's a 0. Negative 5 minus 18 gives me a negative 23, and that is my remainder. And I'm going to have to make a correction in my answer here, since I so wonderfully found out that I wrote it down wrong. This is a minus. Ignore that plus sign, that's a minus. And you see what we did here? I just took the polynomial that I come up with, the quotient. So I got 2x squared minus 2x plus 6, and then I said minus, because this is a negative 23, that means it's going to be a minus sign. And then I put 23 over x plus 3. And so that's my answer. Now, let's jump ahead here and look at the same problem using synthetic division. Okay, the first thing I'm going to do is I have to solve, oops, thought I had my pen, had my pointer. I've got to take this right here and say x plus 3 equals 0. All I'm doing is solving for x. So x equals negative 3, I'm going to put that right there. That's my first step. The next thing I'm going to do is I'm going to take each one of these coefficients and the constant, and I'm going to write them right here. And I got so deleting happy that I deleted my cool little line right here. So let me put that back, get my pen back. So I'm going to take this variable. I've got 2, and then I've got a 4, positive 4. Look, I don't have a linear x. I've got x cubed, x squared, but I don't have a linear x. So I'm just going to put a 0 in there. That's my placeholder for my linear x. And then my constant is a negative 5. Now remember how we did this in class in the general session? I just went ahead and I brought this 2 down. I didn't do anything with it. But now this is where the fun starts. I'm going to take negative 3 and I'm going to multiply it by 2 to get a negative 6. And I put it right there. So now I'm going to add down. I'm going to say 4 minus 6 gives me a negative 2. Then I'm going to say negative 3 multiplied by negative 2 gives me a positive 6. I'm going to add these guys down, so I get a 6. And then I'm going to say negative 3 multiplied by 6 is going to give me a negative 18. Negative 5 minus 18 gives me a negative 23. Now, I'm going to come over here and do my answer reveal. And please note that I did copy and paste from the previous page because it was the same answer. So that means this plus sign got thrown in there again. So let me put a minus sign. So what I want you to see now is that I've got this variable of a 2, and I put it right here in front of the x squared. I've got this, I said variable, I apologize, coefficient. I got this coefficient of negative 2, and I put it right here in front of that linear x. And then I've got my constant of 6, positive 6, which is right here. And then I've got my remainder of negative 23. So I said minus 23 over the sum of x and 3. So, did you see how much quicker we did that? And that 23 again is your remainder. That, I mean, we spent less than half the time working out that problem than when we were working long division. So for those of you who are thinking, ooh, I don't like synthetic, you need to revisit it because it is a time saver. Okay, using synthetic division to evaluate the function at the indicated values. All right, so what they've done is we've got the polynomial. Let me get my pointer. We've got this polynomial right here, and they're wanting us to evaluate it where x equals 2, and again, where x equals negative 3. Let me put my line here and here. It bothers me if it's not there. Okay, so, okay, right here where x equals 2, I just put a 2 here in my little spot, in my little cubicle. I think it's a little cubicle, okay? I got my negative 3 down here. I put it in its little cubicle. So now what I've got to do is bring each of these coefficients. I got a 1, a negative 4, a positive 2, and a constant of 5. And if I look, I've got a cubed, I got a squared, and I have a linear x. So I'm not going to have to use any placeholders. So let's go ahead and bring all this down and get started. Okay, I'm bringing down my 1, my negative 4, my positive 2, and my 5. And remember, I'm just going to bring that 1 down. I don't do anything with it yet. Now I say 2, and you don't have to draw these arrows. I'm just drawing them to help you see the path that I'm taking. 2 multiplied by 1 gives me 2. Negative 4 plus 2 gives me negative 2. 2 times negative 2 gives me negative 4. 2 minus 4 gives me negative 2. And then 2 multiplied by negative 2 gives me negative 4. 5 minus 4 gives me a 1. That, my friends, is your answer. So when x equals 2, f of x is going to be 1. Wasn't that easy? Oh my goodness, we just flew right through that. Okay, I'm bringing those same coefficients down. I'm bringing my 1 down. Negative 3 multiplied by 1 gives me negative 3. Negative 4 plus negative 3 gives me negative 7. Negative 3 multiplied by negative 7 gives me a positive 21. I add 2 and 21, I get 23. Negative 3 multiplied by 23 gives me a negative 69. And then when I add 5 and negative 69, I get negative 64. So guess what? That's your answer there. When y equals f of negative 3, or when x equals negative 3, you get f of x equals negative 64. And I will tell you that to check myself, I went and I entered this polynomial into y1 in my calculator and then pushed second graph, and I looked at the tables and I said, really, when x is 2, y is going to be 1. When x is negative 3, y is going to be negative 64. So I even checked myself to make sure I did that right. And of course, this is just showing the final answer. Okay. Using synthetic division to determine factors of polynomials. Okay, so what we've done so far is we've learned how to use the synthetic division to find our remainder. Then we used it to evaluate. Now we're actually going to use it to find factors. Now, the important thing here is when you're looking for factors, you always want your remainder to be 0. If you have a remainder, you're not going to be able to find the factor. So let's get started. The first thing I've got to do is solve for x right here. And that's so I can find out what is the value that's going to be here in my little cubicle. Okay? I got x minus 6. So you can do that in your head real quick. You can say, well, if it's a negative 6, that means it's going to be a positive 6. But for those who like to see it all written out, I'm going to write it out. And by the way, I am one of those. I like to see it written out. So you're just going to set it equal to 0, and then add your 6 to both sides. So you got x equals positive 6. Now I'm going to bring down each of my coefficients. There's a coefficient there in front of the x squared. I've got x squared, a linear x, and then just a constant of 12. So I'm not going to need any placeholders. So bring down those coefficients, positive 1, negative 4, and a negative 12. You're going to bring down that 1. 6 times 1 is 6. Negative 4 plus 6 is going to give me 2. And then 6 times 2 is going to give me a 12. Ta-da! A remainder of 0. So that means x minus 6 is a factor because there's no remainder. And that's what your answer would look like. And I've tried to give you these answers the way I want to see them on your assignment that you turn in. Okay? So that's why I went ahead and put a little red box around it and everything, because that's what I'll be looking for when I'm grading your papers. All right, let's do the wrap-up. Of course, you're welcome to save this whiteboard. And I'm reiterating that we now have practice problems with answer keys in the lesson, so that way you can use that to check your work before you complete assignment 302 and quiz 302. Be sure to attend your small group sessions this week, and just a reminder that you can submit corrections for the Unit 1 test, Part 1. Please refer to the instructions in the pre-cal course announcements. And thank you for listening, and we'll see you later.